Semester review number 50, find the horizontal asymptote for that function. So if we have a polynomial divided by a polynomial, you can find the highest degree term on top and compare coefficients to the highest degree term on the bottom. Well, we have 2x squared over 1x squared. So the horizontal asymptote is just the ratio of those coefficients, so it's y equals 2. If we had a higher degree term on top, that would be more dominant than the one on the bottom. If it's higher degree on top, then the limit would become infinity because the bigger one's on top. If the bigger degree was on the bottom, then the limit as x goes to infinity would be 0, and it would have a horizontal asymptote of y equals 0. But you can't have a horizontal asymptote if the expression on top is of greater degree than the bottom. So we have y equals 2. If the question asked about the vertical asymptotes occur for numbers that make the bottom 0 unless they're removable. So if we have a factor, so we can see that the bottom is x plus 1, x minus 1. So the domain is everything except for -1 and 1. But we aren't certain that we have vertical asymptotes there because we might have an x plus 1 factor on top that you could cross off, and then there would just be a hole in the graph, and it wouldn't be a vertical asymptote, it would just be a removable discontinuity. Well, the top can't be factored, so there aren't any factors to cross off. So if the question was find any vertical asymptotes, it would be x equals -1 and x equals 1 also. If you look at the graph, here's my horizontal asymptote. You can see that it's approaching y equals 2. And the vertical, you can see that there's a vertical asymptote at -1 and 1. There's a little more information than the question that even asked.